today we are here to discuss two topics about basic calculus. So the first one is the quotient rule and the derivative of trigonometric function. So we hope you will learn something about our group.
According to the quotient rule, g of x and f of x must be two differentiable functions, where g of x is not equal to 0. The formula for the quotient rule is g of x times the derivative of f of x minus f of x times the derivative of g of x over g of x squared. Now, let's take a look on the derivatives of trigonometric functions.
The derivative of sine x is cos x. The derivative of cos x is negative sine x. The derivative of tan x is secant squared x. The derivative of cot x is negative cos secant squared x. The derivative of secant x is secant x tan x. The derivative of cosecant x is negative cosecant x cot x.
Now let's take a look on an example.
For our quotient rule,
Now, let's take a look on an example. Our first example will be h of x is equal to 4x over x minus 1. Now, our first step is to get the derivatives of each term. Our first term, which is our f of x, is 4x. Our second term, which is our g of x, is equal to x minus 1. The derivative of our first term, which is 4x, is equal to 4. The derivative of our second term, which is x minus 1, is equal to 1. Now, for our next step, we have to write the formula of the quotient rule. Our formula will be g of x times the derivative of f of x minus f of x times the derivative of our g of x over g of x squared. After writing the formula, all we have to do now is to substitute. The value of our g of x is x minus 1. The derivative of f of x is 4, minus f of x, which is 4x, times the derivative of g of x, which is 1, over x minus 1 squared. Now, we have to distribute each term to arrive at the final answer. The answer will be 4x minus 4 minus 4x over x minus 1 squared. Now, we need to cancel the unlike terms, which is positive and negative 4x, to arrive at the final answer, which is negative 4 over x minus 1 squared. For the derivatives of trigonometric functions. Now, let's take a look on an example. Our example will be sine x plus 2 cosecant x. As we have done earlier, we first have to get the derivatives of each term. Our first term is sine x, which is the derivative of cos x. Our second term is cosecant x. We have to disregard the value of 2 first for us to be able to solve properly. The derivative of cosecant x is negative cosecant x cotangent x. Now, all we have to do is to solve. For our solution, all we have to do is to substitute the derivative of each of the terms. As we all know, the derivative of sine x is cos x. The derivative of cosecant x is negative cosecant x cotangent x. Now, for our next step, all we have to do is to distribute the signs. Positive times negative is negative, and then using the distributive property, we will distribute the value of 2 to arrive at the final answer, which is cos x minus 2 cosecant x cotangent x.
Thank you so much for watching. Hope you learned something.